Welcome again, ladies and gents, to another flipped lesson. We're continuing on our journey of figuring out how to calculate solution concentration, and the word of the day is molarity. Now, I know you're like, Etnair, come on. Yesterday we learned molality. Today we learned molarity. Those two words sound almost exactly the same, and I completely agree with you. But there's one huge difference when we look at molarity of a solution. In molality, we looked at moles of solvent over kilograms of solute. So we looked at those two pieces individually. In molarity, it's more all-encompassing of the entire solution. So it's how many moles of solute we have per liter of solution. So we're looking at how much volume our solution has at the end after we've dissolved our solute into it. So big M is what we use to represent molarity, and it's moles of solute over liter of solution, or quite simply, molarity equals moles per liter. So in this case, we're looking at, okay, I have my solution volume of 2 liters. I have a total of 4 moles in my solution. So if I put my 2 liters, if I put my 4 moles over my 2 liters, I end up with a concentration of 2 molar. So that means on average I have 2 moles for every liter of my solution. So that's how concentrated I am. So obviously the bigger your molarity, the more concentrated you are, the more stuff you have in that solution. The smaller your molarity, the less concentrated you are, the less stuff you have in that solution. Now unfortunately, we don't really have stuff that weighs in moles. Our scales weigh in grams, so oftentimes we are going to have to do a conversion into moles with these problems. So if we look here, we have a solution has a volume of 2 liters and it contains 36 grams of glucose. If glucose has a molar mass of 180 grams, what is the molarity of the solution? So we know that we're going to use big M equals moles over liter, so we have to go ahead and figure out moles first. So we want to know how many moles are equal to 36.0 grams of glucose, which we know is C6H12O6. I've already given us the molar mass because I'm nice, and so for our units to cancel, we're going to put the 180 grams on the bottom, and we're going to put the 1 mole of C6H12O6 on top. When I do some number punching in my calculator, I end up with 0.200 moles of C6H12O6. So now if I want to figure out what the concentration is, I know I have a 2 liter volume total. I've got 0.200 moles. So I'm going to do my molarity calculation now, where big M equals 0.200 moles over 2.0 liters of solution. So I'm going to enter that in my calculator. I'm going to round to 2 sig figs. And I end up with a solution that is 0.10 molar. So that's not a very large number. So that means this solution is not very concentrated in terms of sugar. So we've got way more water than we do our sugar. Now sometimes I'll be nice and I'll give you the concentration in moles, but I won't give you liters. So a solution has a volume of 250 milliliters and it contains 0.7 moles of NaCl. What's the molarity of the solution? So we're going to go ahead and we're going to work with the same equation here. But what we need to do is we need to change this number to liters. And so if we're going from milliliters to liters, we're going to divide by 1,000. So what that means is I'm going to have 0.250 liters. Well, sorry, I don't need that 0. That 0 is not significant. So I'm going to have 0.25 liters of solution. So I'm just going to go ahead and plug my numbers into my molarity now. So I know my molarity is going to be equal to 0.7 moles of NaCl over 0.25 liters of solution. And when I do that math in my calculator, I end up with a concentration of 2.8 molar. So this is a much larger number than we had on the last example, so that means this is a much more concentrated solution. So basically we just have to understand how to use this guy here. Big M, molarity, equals moles over liters. Go ahead and click on over to the Google form. We got another practice problem for you guys to try on that, and we will begin class by taking your questions and working with that problem. I hope you have a great night, guys.